Now, in this video, we're going to take up one more problem on the shortening or the length of the bar. The problem reads as: a straight bar of 500 mm length has its cross-sectional area of 500 mm square. Find the magnitude of the compressive load under which it will decrease its length by 0.2 mm. Take E for the bar material as 200 GPa. So first, the length of the bar, which is 500 mm length, you take it as 500. Its cross-sectional area, decrease in length delta L is 0.2 mm. And then the area of modulus of elasticity is 200 GPa, which is 200 into 10 to the power of 3 Newton per mm square. Then we have the area of cross-section of the bar A, which will be equal to 500 mm square. Now, what is strain? Strain is nothing but delta L by L, that is the decrease in length by the original length. Substitute the values of delta L and L, which will be equal to 0.2 by 500. So that will be equal to, on calculation, which will be 4 into 10 to the power of minus 4. Now the Young's modulus is given by stress by strain, which is equal to sigma by epsilon. We know the value of Young's modulus and the epsilon, so we can find out the value of stress. Substitute the value of Young's modulus, which is 200 into 10 to the power of 3, divided by, that is equal to sigma by 4 into 10 to the power of minus 4. On simplification, the stress will be equal to 80 Newton per mm square. Also, what is stress? Stress is nothing but the applied compressive load by the cross-sectional area of the bar. That is equal to P by A. So we know the stress, which is 80 Newton per mm square, which we have calculated. That is equal to the load applied, which I need to find out, P divided by the cross-sectional area, which is 500 mm square. So therefore, P is equal to 80 into 500, which is equal to 40,000 Newton. So convert the 40,000 Newton into kilonewton, which will be equal to 40 kilonewton, which is the compressive load. Or we can also find what is the decrease in length, which is delta L will be equal to P into L by A into E. So here delta L is known, which is 0.2, which is equal to P into L, length of the member, which is 500 divided by A, which is 500 into 200 into 10 to the power of 3. On simplification, you're going to get the compressive load P will be equal to 40 kilonewton. So this is how we will be able to calculate on both the methods. Now we're going to take up one more problem. A brass rod of 1.5 meters long and 20 mm diameter was found to deform by 1.9 mm under a tensile load of 40 kilonewton. Calculate the modulus of elasticity of the rod. So the data are given, which is the length of the rod, which is 1.5 meters long, which is 1.5 into 10 to the power of 3 mm, which is 1500 mm. And the diameter of the rod, which is D, will be equal to 40 mm. And then it was found to deform under a tensile load. So that is the extension or the deformation of the rod delta L, which will be equal to 1.9. And the tensile load, which will be P, applied tensile load, which is P, will be equal to 40 kilonewton, which is 40 into 10 to the power of 3 Newton. So what I need to find out is the modulus of elasticity of the rod. So area of the cross section of the rod as the diameter is given. So since the cross sectional area is the circle, so obviously area of circle is pi d square by 4, which will be, substitute the value of diameter as 20. Therefore, pi by 4 into 20 square. On simplification, we're going to get it as 314.16 mm square. Now, what is the stress? Stress is nothing but P by area of cross section, which is the applied tensile load by area of cross section of the rod, which is P by A. So we know the value of P, which is 40 into 10 to the power of 3, and divided by, we know the area of cross section, which is 314.16. Substituting these values on calculation, you are going to get it as 127.324 Newton per mm square. Now, similarly, you want to find out the strain. What is strain? Deformation of the rod by the original length of the rod. So what is the deformation of the rod, which is delta L by L? You know the value of delta L, which is 1.9, by the length of the rod, which is 1500. So on simplification, you will going to get it as 1.2667 into 10 to the power of 3 minus 3. So that is the strain value. So what is Young's modulus? Young's modulus is nothing but the stress by strain, which is sigma by epsilon. You know the value of sigma, which is 127.324, And you know the value of epsilon, which is 1.2667 into 10 to the power of minus 3. On simplification, you will go to get it as 100.5 into 10 to the power of 3 Newton per mm square, which is equal to 100.5 GPa. So that is E will be equal to approximately 100 GPa. So in the other method, if you deformation of the rod, delta L will be equal to P into L by E into E. We know the value of delta L, which is 1.9, which is equal to, we know the value of P, which is 40 into 10 to the power of 3, and we know the value of length, which is 1500, divided by the area of cross section, which is 314.16, which has been calculated, into Young's modulus, which is E. So on simplification, the Young's modulus will be equal to 100.5 into 10 to the power of 3 Newton per mm square. So which is again, E will be equal to 100.5 GPa. So since this value and these values, which are almost both one and the same, and hence this will going to be the final solution. Thank you.